I'm going to discuss classes and objects. This is our lesson number 1 in object-oriented programming in Java course. Before we discuss, let's look at this scenario. Okay. It says there are students and teachers in an educational institute. That means there is a particular educational institute. Okay. There is a particular educational institute. There are students. Okay. There are students and teachers. The institute conducts a course which consists of 2 subjects, mathematics and English. And in this institute, they conduct a particular course. That course contains 2 subjects, mathematics and English. Okay. So these students have to sit for 2 examinations at the end of the course. That means 1 examination for mathematics, another examination for English. The students are graded based on their average marks. They are given grades and the grade is based on the average marks. The salary of a teacher, if you consider the salary of a teacher, salary of a teacher, that is computed from number of teaching hours. Okay, number of hours of teaching. Okay, so now we know for the students we need to grade them. Okay, in order to grade them, we need to compute the average marks. Okay, those are the things we have to do. And then suppose we have to develop an information system for this simple scenario. Okay, so before we begin, I introduce a particular concept. What do we understand by a class? Okay, what do we understand by the term class? Okay, that means a template that represents the entities with common attributes and methods. It is a template that represents the entities with common attributes and methods. Okay, so in this scenario we can identify 2 classes. Okay, many other classes are also there, but we can identify 2 classes. One particular class is a student. One particular class is a student, and we use this notation. Okay, so we use this notation for a class, this rectangle student, and if you consider one particular student, he or she has common attributes. Each student has a name. Each student has an age. Okay, and if you consider each student, they earn marks for mathematics, marks for English. So they are also attributes: marks, maths, marks, English, then average of these marks, average, and this is the average marks of one particular student. But there are many students in this educational institute, no? There are many students, and average means average of one particular student. Okay, if you consider one particular student, average marks of that student. When we consider all the students, average of all these average marks, we represent it, let's say, using AVG. And there are now, this is our notation for a class. Okay, and then these are the common attributes of students. These attributes are common to all the students. And what are the methods common to all the students? One thing is, you have to calculate average then based on the average, you have to calculate the average of one particular student, and based on the average you can compute grade of a student. Okay, so let's say we want to get the grade, and then using all these averages of each student, we want to compute the whole average, AVG. Okay, so that one also can be included, cal AVG, a method to compute the whole average. Okay, so this is our student class. And again, for the teacher, there are teachers in this institute, therefore each teacher has a name, and each teacher has an age, and number of hours, salary depends on number of hours they teach, and therefore number of hours they have taught during a particular course. Okay, during a particular course, number of hours they have taught, you have to include it here. And rate means, in order to compute the salary, how much we pay per 1 hour. 1 hour, how much we pay. Okay, so that is the rate, and then after that we can compute the salary. That is another attribute, and now you can see these attributes are common to all the teachers, and as a method you can include salary, calculate salary, cal salary method. And now in these are two classes, these are templates, okay, and this is the graphical notation. Graphical notation for the student class and for the teacher class. And here you have to remember, we have to always use the singular form. Not, this is student, okay, not students. Here it should be teacher, not teachers, okay. We always use the singular form. And if you look at the attributes of the class is student, they are name, age, marks maths, marks average, marks maths, marks English, average AVG. Okay, this is the average marks for one particular student, average marks of these two. Okay, and this is the whole average. That means average marks means average marks of one particular student. AVG means the average of all the average marks. And attributes of the class teacher, they are name, age, hours, rate and salary. Again, methods of the class student, they are cal average, get grade, cal AVG, and methods of the class teacher, cal salary. Now you have learned what is a class. What is a class? Now you have understood. So another concept is their object. Okay, object. What is the difference between a class and an object? Okay, so in order to understand the difference, let's say there is a particular student, name A, okay, name of the student is A, and age 23, marks maths 67, marks English 84, average average we have to compute it, no? Let's say we have not yet computed, therefore we can put 0.0. And AVG also we have to compute, we have not yet computed, therefore for the time being we can put it like this. And now consider this and this. So this is a template for a particular student. Here you do not have values for each of the attributes, but this one is a particular student. Okay, so this is an object of the class student. That is the difference between a class and an object. Okay, that is the difference. The attributes name, age, marks maths, marks English are given as inputs when creating the object. Okay, so these values name, age, marks maths, marks English, those are given when we create the object. Okay, the attributes average and AVG, those two attributes should be computed by the system. Okay, so still we have not computed, that is why actually we have to compute the average of these two values. Still we have not done the computation, therefore default value we have put it as 0.0. Here the values of attributes average, AVG have not yet been computed and they store their default values. Then another thing, now what is the difference between a class and an object? Okay, what is the difference between a class and an object? Then the difference between class and object, that means now let's again go to the definition of a class. A template that represents the entities with common attributes and methods. That means student. If you consider student, this is a class. Okay, that is just a concept. We cannot see student, but if we say Nimal is a student, and Nimal, the name of Nimal, we have Nimal, and for the age we have a value. Okay, for the marks maths we have a value, for the marks English we have a value. Likewise, for the attributes we have values. Therefore, object means object is an instance of a class. Object is an instance of a class. Okay, that means the difference. What is the difference between a class and an object? Class does not have values assigned to the attributes, whereas the objects have. That is the difference between a class and an object. Then now we are talking about Java programming language. What is a Java program? What is a Java program? What is a Java program? That means a collection of classes is called a Java program, nothing else. A Java program is a collection of classes, and now you know how to graphically represent a class. There are three parts. No? Here we put the name of the class, here the attributes, here the methods. The set of attributes and the set of methods of a class are called state and behavior of the class separately. And here we put the name of the class, and here we put the state. That means set of attributes you have to list in this section, and in this section we have to include the set of methods, and that is the graphical notation. Okay, graphical notation of a class. I have already discussed this graphical notation. Graphical notation of a class. Then let's see. There are 8 primitive data types in Java. They are boolean, byte, char, short, int, long, float, double. Okay, and these are the data types and their default values. Default values means once we declare a boolean variable, and if we do not set a value, if we do not assign a value to that variable, it holds false. Okay, that is the meaning of the default value. Okay, and that means another example, if we declare an integer. Okay, so for an example we declare int x. This is how we declare variable in Java programming language. Okay, so here the value of x, if we print the value of x, we can understand it is 0. Okay, this step is called the declaration of the variable. Declaration of the variable. If we assign a value by ourselves, this kind of a step we call initialization. Then now you can see the default values of all the 8 primitive data types in Java. Now let's see this paragraph. Now let's try to implement using Java programming language. Create a folder called codes. Now it's some exercise like thing, no? So we are asked to create a folder called codes. We need to create a folder called codes. Okay, our name of our folder is codes. Create two Java files. Two Java files is inside this. One particular Java file is student.java. The other one test.java. Those are the names of the two Java files. The contents of those files should be as follows. Okay, so these are the contents. Now let's try to do this one. Let's go to the desktop. There I have already created the folder called double OP. Inside this folder, let's create our codes folder. Okay, codes. Inside this one, we are asked to create two Java files. Then we have to open Notepad. Okay, so one particular Java file, let's try to create. It is class student char name int age double marks maths double marks English double average. Okay, this is our student class, and now we want to save it inside our codes folder that is on our desktop. Okay, so inside this folder, now here you have to select all files, and here within double quotations you have to use the same name as the class name. Okay, here you have to use the name exactly same as the class name and put a dot, then use the .java extension. That means this is a Java file. Now let's close this one and see this. Here you can see it is a Java file. Okay. Now again we have to create another Java file. Let's open Notepad again, and here you have to include class test. Here we include the main method. Okay, here we include the main method. Public static void main string args. In this way you can include include the main method. For the time being we keep the body empty. Now you can see the name of this class is test, therefore we have to save it using the same name here inside the codes folder. Here you have to select all files and test.java. Those are the two Java files we have created, and it says we have not yet included everything inside the class student for the time being. Okay, that means our student class file is still incomplete. The class test contains the main method, that is this one, our main method. You can see the name main method. So we have to compile and run the class test only. Then now you know a Java program means a collection of classes. Now in order to run your Java program, you have to compile and run only the class where we have the main method. You have to use command prompt to compile and run. You must be inside the folder codes in order to do that. So first of all, let's start the command prompt. Okay. This is the command prompt, and you have to go inside the folder codes. That means the path of this one. So here you have to use the cd command and put the path. Now we are inside this codes folder. Now you can see we are inside the codes folder. Okay, this path is little bit different than I'm using, but anyway, now in this command prompt also I am inside the codes folder where we have saved our files. Okay, uh, and this one explains a little bit about the commands used in command prompt. Okay, now in order to now run, first what we do is, okay, I hope you have basic understanding about Java. First we have to compile, then run, then using Java C command we can compile, using Java command we can run. Okay, so here I use Java C test.java. You have to wait until it gets compiled. If you do not see any errors, that means your program has been compiled successfully. Then in order to run, we use Java test. Now it has run, but you do not see any output. The reason is the execution of a Java program starts within the main method, and main method is empty for the time being. Therefore, you do not see anything. Nothing happens when we execute this code. Okay. And the other thing is, for this test class, here we have the main method. Therefore, we call a special name for this test.java file. Okay, this class. Okay, this class we call it driver class. Okay, because it drives your Java program. Here test.java is our driver class. Every program must have exactly one driver class. The execution of the program begins inside the body of the main method. Therefore, in order to run, every Java program must have a driver class. Okay, driver class is where we include the main method, and execution of the Java program begins inside the main method. We can create an object from our class student as follows. Okay, then now you know these things we have finished. Okay, now you know this is our class. This is our class file. And if we want to create an object from our class student, then what should we do? First, we use student. Okay, it is something like this. we do something like this. We declare an integer variable. This is also something like that. We declare a variable of type student. Okay, this is also something like that. And then this is a keyword. Okay, and we do something like this. Okay, so later I will explain what we have done. For the time being, you have to understand we use the class name and empty parenthesis in order to create an object. Okay, for the time being, you have to think it like that. Okay, so here what happens? Here what happens? Now our Java program, it executes this line first. Okay, so these two lines we have to include inside the main method. No, inside the main method we have to include. So in memory of the computer, there are two parts. One part is called the stack. The other part is called heap. Okay, so when we do this S variable is created on the stack. Okay, and if you consider something like this, int x, this line, this one, in that case also variable x is created on the stack memory. That means these variables also behave like this kind of variables of primitive types. Okay, behavior is something somewhat similar, okay, to these variables. And now new means a keyword. When we execute this line of code, an object of type student is created on the heap memory, and in our variable s, memory location of this object is stored. Okay, so we represent it like this using an arrow. This means the memory location of this object is stored in the variable s. Okay, that is how we graphically represent it. Okay, so the first line declares a variable of type student. Okay, that is our first line. It is called a reference. It is called a reference variable and created on stack memory. Okay, it is created on stack memory. It behaves like normal variables, int x, double y, etc. In the second line, the keyword new creates an object of type student and assigns its memory location to the reference variable s. Note that the objects are always created on the heap memory. Okay, so here you have to understand the objects are always created on heap memory. Okay, that's what you have to understand. Then modify your test.java file as follows and again compile and run. Now we know that an object is created, but we do not know what is it. Okay, in order to understand, let's edit our code. Uh, we have to go to our test.java file. There we edit it like this. Okay, now object was created, but in order to see, we use this one. There we access s dot name. Okay, so I will explain the purpose of dot later. For the time being, let's okay. So here you can see, and let's look at the student class again. There are 1, 2, 3, 4, 5. 5 attributes are there. Here we have 5 attributes. Now here we use dot, no? So I'm going to explain the purpose. Okay, that dot is called the dot operator. Dot operator to access attributes of an object. Following figure shows the output in command prompt. Okay, so if we look at the output, we can see here the output. Before that, I will explain what happens here. Okay, so one thing is, when we were talking about primitive data types, I have explained you, if you declare variable like this, okay, even if you do not assign a value to this variable, there it holds its default value. Okay, so if we print the value of x, you will see it prints 0. That means 0 is the 0 is the default value of the variable. And similarly, now we created an object. Okay, we have not specified the values for its attributes. Therefore, those values contain their default values. Okay, that means there are now in our here name now it is a the data type is char, no? Data type is char. Therefore, what is the default value? Let's go back and see. Char. It is something like this, no? It is something like this. U 4 zeros. It is something like this. Okay. So again, if you look at the age, the data type of age is int, therefore default value of int variables, that is 0. The next one, marks maths. The data type is double, their default value 0.0. Okay. Then marks English, their default value 0.0 because that is a double variable. And average, that is also a double variable, therefore the default value is 0.0. Now when we display, you can see the output like this. Okay, let's try to get the output by ourselves. Now again, so first one is empty. Okay, you do not see anything. That means this one, when we display, we do not see anything. That is why first line is empty. Then this one 0 and these three values you can see. Okay, here. It says we did not assign values to the attributes of the object. Therefore, Java automatically assigns default values to the attributes. Okay, default values have been assigned to the attributes. Okay, default values have been assigned to the attributes. We can use dot operator to assign values to the attributes of an object as well. Then Java, yes. Here, I forgot to talk about the dot operator. Okay. Then here you can see we have used dot operator. Now, in order to access value of attributes, this is called the reference variable of this object, because this is a reference variable to this object. Okay, reference variable to this object. That means this variable holds the memory location of the object, and we can access each of these attributes s dot using the dot operator. Okay, this is the dot operator. Dot operator. Dot operator s dot name, something like that. We can access the name attribute s dot name, s dot age. Okay, using that one we can access the age attribute. Likewise, we can access attributes in that way. Okay. And also we can use dot operator to assign values to the attributes of an object as well. Then test.java file is as follows. Now we do something like this. Okay. Before we display values, what we do is now here we can see this one. Okay. After execution of these two lines, you will see this. Okay. Then here we do some other part. Okay. So what we do is s dot name. In this way, s dot name. That means our reference variable dot name. We can set a value. Let's say a. That means this value will be replaced by a. Okay. Then s dot age 23. Then here 23. Again s dot here it should be s dot. Okay, there is a little mistake. It should be s dot. S dot marks maths. S dot marks maths. It is 67. It is 67. Okay, then the other one s dot marks English. It is 84. 84 here. Yes, here after putting 84, this will become by the execution of this line, this will become 84. Okay. Now let's see. The output, and let's include those parts here and see the output. S dot name a, s dot age 23, s dot marks maths 67, s dot marks English 84. Okay, like that. You can see that part. Okay, so now let's run and see. you can see the values. Now 23A is the name, 23 age, 67 marks maths, 84 marks English. This is the average, it is 0. Okay, now you can see the output. Okay, and that is the end. Okay, then we need to discuss an exercise. Create following student objects. We have already created the first one. Okay, this is our exercise. We have finished creating the first one. Okay, then we have to create a student S1 equals new student. Okay, then S dot name, to that we assign B. S dot age, we assign 34. S dot marks maths, we assign 45. S dot marks English 88. Okay, so this one A 23 67 6. Yes, here it says 64. No, this should be corrected as 84. Okay, 84. Student S2 S2 we assign using the new keyword new student. S dot name See, yes, here I have made a mistake. Here it should be S1, okay, and here S2, S2 dot age, it is 22, S2 dot marks maths, okay, here C22 marks maths 29, S2 dot marks English, it is 93, student S3, S to the S3 we invoke student, S3 dot name D, S3 dot age 17, S3 dot marks maths 74, S3 dot marks English, that should be assigned 38, okay. Then it says compute the value of the attribute average for each object, okay. In order to do that, now let's try to draw this one, okay. So here you have yes, we have created 4 objects. Now you know the stack memory is there and heap is there. So we created S and S1, S2, S3. Here we have created objects, this one, this one, this one and this one. So this stores the memory location of this object, this stores the memory location of this object, this stores the memory location of this object, and this one stores the memory location of this object. And here we have name attribute, there we have put A, then age attribute, here we have put 23, marks maths 67, marks English 64. That is a mistake because in previous situation we have used 84, no? So here it should be corrected in this table. You have to correct it to 84, and there is another attribute. Not only 4 attributes, there is another attribute in our student class. Okay, so here if you look at this, average is the other attribute. Therefore we did not assign a value, therefore it contains its default value, average 0.0. Okay, then the next one, name is B, age is what is the age? 34. Marks, maths, marks, English, average. Marks, maths means S1 marks math, then marks math 45 and 88. 45, 88, here 0.6. Okay, same way here also we have name, age, marks, maths, marks, English, average. Here also we have name, age, marks, maths, marks, English, average. Okay, in that way you have values. So if you look at S2, here C22, C22, 2993, 2993, this one 0.0. Then S3, this is D, 17, 74, 38, 17, 74, 38, this one 0.0. These are the 4 objects created on the stack. No, not created on the heap. Okay, these 4 variables are created on the stack memory. Okay. Now we need to compute the average for each object. So in order to do that, we can access a S dot average. S dot average we assign to the S dot average, we can assign S dot marks maths. Okay, so I will write this somewhere. The space is not enough, so I will write it in this way: S dot average. Okay, so marks is S dot marks maths plus S dot marks English. These two we divide by 2. Okay, this should be written in a single line. Okay, you cannot split it into multiple lines, but since I do not have space, I have written it in this way. So In this way, we have to add them these two and divide it by 2. That is how we compute the average. Okay. So here we use the dot operator. Okay. So let's include that line in our code as well. S dot average, that is equal to S dot marks maths plus S dot marks English. That is one particular line. Here it should be S1. Here it should be S2. Here it should be S3. Okay, likewise we can do that. So let's compile and run. Okay, it gives the average of the first one 67 plus 84. This one 67 plus 84 divided by 2. 75.5. Okay, 75.5. Okay, so that value has been assigned here. After execution of this line of code, this will be changed to 75.5. Okay, in the same way, we can display other values. If we put S1 here, $66.5 here, 66.5, then 61. This one is 61.0. Simply let's say 61. Then the last one. Okay, last one. That is S3. $56. This one 56. 56. Okay. Now we have finished the exercise. Then let's move to the next line. Suppose we execute following line of code. Let's say we execute S. This is in Java. What do we understand by this? This is the equal sign, but it's not the equality operator. It is called the assignment operator in Java. It is the assignment operator in Java. Okay. So what happens here? This S1 and S are two variables created on the stack. No? Here the value of S will be created to assign. The value of S1 will be assigned to S variable. That means value of S1 means the memory location of this particular object. This object. Okay, this object. So one variable can hold one value at a time. Therefore, to the S, now it also points this object. Now this object has two reference variables. S and S1. There are two reference variables to this object. Okay, so let's do this in our code. So in this situation, even if we display it displays the details of this object. Then again let's try to through S1 using S1 reference variable. In that situation also it displays the details of this object. Okay, therefore now I hope you can understand the assignment operator applied to reference variables. Now it says the other thing you should know. Now the variable S stores the memory location of the object with the name B. Okay, that means this one. And the variable S1 also stores the memory location of the object with the name B. However, no variable stores the memory location of the object with the name A. That means this one, no variable is referring the memory location of this particular object. Okay. Therefore, the object with the name A will be destroyed from the memory. Now, here no variable is storing the memory location of this object. Therefore, no one can access that object. It's useless. Therefore, in Java, usually this object will be destroyed automatically. Java will destroy this kind of objects. Objects can exist as long as they have references. Okay, here no references are there, so Java will erase this object, delete this object from its memory. Okay, the objects without references are automatically deleted from the memory. Okay, that's a rule in Java. The attributes can be divided into two categories. Now you know the graphical notation. In the graphical notation of a class, now you have seen it has three parts. Here we include the name of the class. Here we have the set of attributes. We call it the state of the class. Okay, here we include the set of methods. We call it the behavior of the class. And now the set of attributes can be divided into two categories. Instance attributes and class attributes. What we have discussed so far are instance attributes. Okay, that means if you consider, we were talking about average. The attribute average, that means if you consider students, each student can have different average values. Okay, this student may have 52.5, 62, 31, 46.5, something like this. For the average attribute, each object can have a separate copy. Okay, each object has a separate copy if it is an instance attribute. But let's think we want to store the average of all the averages. That means the whole average marks of the class. We store it in AVG variable. So let's compute the value of AVG variable. 52.5 plus 62 plus 31 plus 46.5. We have to divide it by 4. 48. That means this value is 48. Okay, so if we ask from this student what is the whole average, he or she will say it is 48. this is the average, this is the AVG value. Okay, and average. Okay, then if we ask from this student, he or she also will say 48, here 48, here also 48. Therefore, in order to store the value of AVG attribute, we do not need the separate copy for each object. Okay, maintaining one copy is enough. Maintaining one copy is more than enough. Okay, but in order to store average, we need to have separate copies. Okay, because they can have different values. Okay, therefore we can declare this one as a class attribute such that we can maintain only one copy for all the objects. Therefore, in order to do that, we have to use the keyword static. Now, let's see, it says instance attribute means an instance attribute is an attribute defined in a class for which each object of the class has a separate copy. Something like this, separate copy. Okay, and class attribute means a class attribute is an attribute defined in a class of which a single copy exists regardless of how many objects of the class exist. So we do not have to keep separate copies for all the objects. We can maintain a single copy. Okay, because for all of them this is common. In that case, we can declare such variables as class attributes. Okay, so in order to do that, we use a static keyword. The attributes name, age, marks, maths, marks, English, average are examples for instance attributes. The attribute AVG is used to store the average marks of each student. That means AVG stores the whole average. Okay, there is one AVG value for all the students, and it should be a class attribute. We use keyword static to distinguish class attributes. Now let's modify the two files as follows. So student class, here we add static keyword. We have to use static double AVG. We add that attribute. Okay, so main method, we have to modify it. Student S1 equals new student. Okay, let's explain it using the whiteboard. then when we execute this line of code, then let's use this is our stack and this is our heap. Okay, so S1 variable will be created on the stack and this one will be created, the object will be created on heap. Okay, and in this situation, if you consider the name attribute, we have not assigned any value, therefore it holds the default value. Let's look at the student class. Name, age, 0, marks, maths 0.0, marks, English 0.0, average 0.0, okay, and then ABG 0.0. Those are the 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Those are the 6 values of the 6 attributes. Now we know that the variable AVG is a class variable. Therefore, in order to distinguish it, we can underline it. Okay, that is a standard notation used to distinguish class variables from instance variables. Then when we type the next line, student S2 okay, in this situation here you have S2 and another name 0006. Yes, here 40 should be there. Okay, so name age 0. Okay, marks maths 0.0, marks English 0.0, average that is 0.0 and AVG that is 0.0. This is a class variable, so we underline this something like this, and this variable refers this object. That means memory location of this object is saved inside this variable. And now what we are going to do is S1 dot AVG, we set it to 10. When we execute this line S1 dot AVG, okay, S1 dot AVG, then we put a value there, we put 10. That means this one is going to change, no, to 10, but not only this, because there is one copy, even though we have shown it in both places, only single copy, because that is a class variable, class attribute. Therefore this one will also automatically change to 10 when we execute this line of code. Okay, then let's see. Now if we try to display s2.avg, that should also display 10 instead of 0 if what I have explained is correct. Okay, therefore let's try to run this. There is an error. AVG, it says let's okay, because I had forgotten to save my work, that's why earlier we got an error. Now again if we run this, you can see 10 instead of 0. That means we change this one, okay, but there is only one copy AVG, therefore definitely this will also be changed to 10. Okay, that's the thing. And the other thing is, that means whatever we access, whether we access it as s1.avg or s2.avg, okay, through both of these lines we access the single copy avg. Okay, therefore if the attribute is a class attribute, we can access it using class name dot as well. Okay, in this way also we can access class attributes. Okay, we can do this only for class attributes. Therefore now let's see here let's try to access a student. Okay, you can see. Okay, in that way you can access class attributes as well. This will give 10 as the output. The AVG variable is common to all the objects. Therefore, following 3 lines do the same thing. Okay, that's what I have explained. This can be done only for class attributes. You have to understand logically that doing this is useless and meaningless for instance attributes. Okay, that is the end of our lesson 1, and thank you for listening.